things that are close by. So notice how the light, we have something that's close to your eyeball. The light is originating from something close to your eyeball. I just want to kind of point this out because I kind of glanced over it here. Whereas in this previous example, the light rays were parallel. Because if something is super far away, how far out can I zoom on this PowerPoint? This is not doing what I wanted to. Draw it way over here. You can see why something far away, the light rays are parallel looking. Whereas when something is close by, not, because it's close by. So, to correct this, yeah, you put a lens right here. That's going to take this light and go ahead and kind of convert it in a little bit. You know, depending on the lens, it's going to depend upon how much. So it's going to make it a little bit tighter. And if it makes it a little bit tighter, that means it's going to focus a little bit sooner, which is the whole goal. What's kind of interesting is, I don't know about you all, but when I look at my contact lenses, they do not look like this shape at all. No one's does. So what they do, something that you're like, but contact lenses don't look like that. So here's a contact lens. What you can't tell, it's really subtle. So this contact lens bows in a little bit on this and bows in a little bit like that. And you get a little one of those lenses kind of in there. But it's so thin that you all can't tell with your eyeball. But just note that it's making the shape in the lens still. Literally the part that's above your eye is just a little bowed in. Whereas the part for this, if you're using a contact lens to correct for this, it's going to be a little bit more fat kind of in the middle. That's an exaggeration. You cannot tell that by, it's so thin. That's why contact glasses are so, and the reason contact lenses can do this is because they're so close to your eyeball, they don't have to vary much to affect the light significantly. They're so close to your eyeball, they can kind of just do a little bit and it changes a lot. That's at least what I think. I haven't looked into this, to be honest. I'm just kind of spouting what I think is true. So fact check me on that. I'll be. It all makes sense logically. So, but I'm pretty confident. You know, look into it. Tell me if I'm wrong or right, or maybe I will. Probably won't. But I probably should. But you know, full disclosure, y'all. All right. Great. Okay. So that's what lenses do. That's how they work with eyeballs. The last thing I need to teach you all is this equation. This is the last equation. Is it the last equation in the entire class? Okay. There's technically one. Here, let's make it the last equation in the entire class. All right. We'll talk about P in a little bit. Ta-da! That's the last equation in the entire class, y'all. Yay. How exciting. We'll talk about P later on, but it just gets chucked on there. 1 over the distance of the object plus 1 over the distance of the image equals 1 over F. The rules, DO is always positive. Always positive. DI, or F, so these rules, the rules for DO and F are really easy to remember. And I'm going to do my best to make the rules for DI really easy to remember. DO is positive, always, always. When you plug DO into these equations, it will always be positive. You're working with mirrors, positive. Working with lenses, positive. DO is always positive. F is always positive for converging. Converging lens, F is positive. Converging mirror, F is positive. Diverging lens, F is negative. Diverging mirror, F is negative. Rules, super easy. DI. How do you remember the rules for this? DI is positive when the light rays meet. DI is negative when they don't. Long story short, if it actually happens, do I have a real image? DI is positive if you have a real image. DI is negative if you have a virtual image. And that is terribly hard to read. Virtual. Real. That's the way to remember this, y'all. If you're working with mirrors, the same rule holds. If the light rays come together, DI is positive. If the light rays don't, DI is negative. Does it actually happen? Is the image actually there, or is it a fake thing, i.e. virtual? So that's the way I remember this. And how do you know if it's real or virtual? Does it make sense? A lens, the light should go through it and the light should kind of come together. That makes a real image. If the image is on the same side as the object, that's just weird. Like, let's just kind of draw a picture and show you what I mean by that's weird. Look, here's my object. My image is on the same side. What the, like, how the heck? The light's supposed to go through the thing. So yeah, it's a virtual image because what the heck, light's supposed to go through a lens, not be on the same side. That's the way I remember it. For a mirror, which again, you do not need to know for my class. For a mirror, what is the side that doesn't make sense? If you have an object here, so this is a mirror, and I'm going to erase this thing afterwards. Yeah, if your image is on the other side of the mirror, that's weird. Light doesn't go through mirrors. That's a virtual image. DI is negative. Where does it make sense for light to be? If it's on the side that makes sense, it's DI is positive. If it's on the side that doesn't make sense, DI is negative. That's the way I remember it. To be honest, if you're worried about forgetting it, just write it on your formula sheet. Just write it on your thing. DI is negative. DI is positive. There you go. The DI is the hard one to remember. The other ones, DO is always positive, F positive for converging, F negative for diverging. All right. Let's see. We got 6 minutes. Do we even want to risk a clicker question? Yeah, sure. Why not? Is the answer... Yeah, this is fine. Is it fine? How did I mess this up? All right, let's go ahead and fiddle with these things because the answer isn't here. Don't know how that one slipped through. Oh my gosh, the answer was there. Sorry, y'all. It was there all along. I did something. I will tell you the stupidity I did. Trust past selves, y'all. Maybe. I'll tell you the stupidity I did once you get the answer. You are getting the right answer, so that's good. And we'll end it with this one. So the equation, just in case you didn't have it down, 1 over DO plus 1 over DI equals 1 over F. All right, we'll go to 140 and then call it good. Yeah, I'll go a little bit longer. We'll go to 150. Maybe longer? Should I go longer? All right, I'll close it out in 5, 4, 3, 2, 1. All right, y'all, so let's unpack this. This is a classic plug and chug situation. The only thing you got to check is whether they should be positive or negative. What's given? DO is always positive. Always. I don't care what problem I give you. DO is positive. Says the object's there. It's positive 2 meters. F. Is it positive or negative? It's a converging lens. F is positive. If it's converging, positive. Diverging, negative. What are we solving for? DI. Do we care whether it's positive or negative? No. The math will tell us. You only have to decide the sign for part 1. Part 2, let the math do the work for you. So easy peasy, plug and chug. 1 over 2 plus 1 over DI equals 1 over F. And you're going to immediately see where I goofed. Oh, let me write the equation without... Well, I already wrote it. I'm going to put the numbers in. All right. So, you know, 1... This is just 1. So we're going to have 1 minus 1 half. So 1 over DI equals 1 minus 1 half, which is just 1 half. And you can see why I was like, oh, 1 half's not one of the options. But I didn't say find 1 over DI. I said find DI. Now, you can look at this and say, okay, di is 2. How do you actually do this? So pro tip with this equation. No matter what variable you're solving for, f, di, do, doesn't matter. The final result is going to be to take what's on the right and do 1 over that. That's how you flip it. How do you get the thing that's on the bottom out of the bottom? 1 over the other side. You do the inverse. So for example, if you all want to solve for f in this equation, f is 1 over do plus 1 over di. If you want to solve for do is 1 over f minus 1 over d, so on and so on. So long story short, no matter what in these problems, you're going to end up doing 1 over something at the end. And 1 over 1/2 is positive 2. There it is, y'all. Again, I doubted myself. Shame on me. It's not 1/2, it's 2. And you can check the math. 1 over 2 plus 1 over 2 is 1. There you go, y'all. Yeah, we'll call it good there. Ooh, the next one's going to be diverging. Do that on Tuesday. Have a great weekend, y'all. It's the same, but I'll let y'all kind of... The answer is in here. I'm going to double check my own work. We'll find out. Together. And by together, I mean, I'm going to check it right now so I don't make a goof out of myself next time. Yeah, it's in here. I was like, there shouldn't be any typos. Last year was the class that suffered typos. Have a great one, y'all. See you on Tuesday, and we'll finish out 8 last slides of this quarter semester.